Pipeline field joints have been the focus of our attention over the past few weeks, and we've spent some time looking at some of the aspects of their repair. Now, the particular challenges of working in the field have been reiterated many times, and we've talked about the impossibility of controlling the environment and the physical constraints during application due to the trench size. And we've also looked at how those impact any of the field joint repairs, irrespective of which coating we look at. Now, today, we turn ourselves inward, inside the pipe to be exact. And when we thought we had space constraints in the trench, I think the response from today might be, well, you ain't seen nothing yet. And just to give you an idea of that, there's the picture of the space constraints that can occur when we're trying to get on the inside of our pipeline to coat it. Joining me today to discuss the joys and more likely the challenges of internal field joint repair are Ben van Wyk and Arto from StonCor. Now, Ben is no stranger to bite-sized corrosion. In fact, Ben was our very first guest almost 3 years ago. And Ben is the engineering manager at StonCor, and he has a special interest in fire protection and corrosion protection. And joining him is Arto, and he's the technical services manager. So he's got a lot of hands-on experience of protecting steel. Together, they're going to make a great team to help us explore this field of internal linings for field joints. So a warm welcome to both of you, gents. So we've discussed the repair of external surfaces of our steel field joints and want to look at the inside of the pipes. Ben, what do we need to consider?
When we talk about repairing the inside of the pipes, the scenario changes, and in fact, the whole topic and discussion will vary quite a bit, depending on the pipe size and the material that the pipe is made out of, steel or GRP or something else. Then how the pipes are connected is going to play a big role, whether they might be flanged or coupled or spigot and socket type connections or welded. What the internal mainline factory coating type is, whether that's typically CML or epoxy. So yeah, but just to narrow it down for this session, we'll focus on welded steel pipes.
Super. Thank you, Ben, for focusing us for today. And it seems a little obvious, but we mustn't lose sight of the fact that our objective is now to, as you said, change our focus looking on the inside to make the internal lining of our pipe continuous by coating that bare portion at the joint. So what would be the most common materials that we would use?
Yeah, so when the factory or mainline coating is applied, a small gap is left at each edge of the pipe to accommodate welding on site. So if the factory or mainline coating is epoxy, you're going to be painting a strip of about 250 millimeters wide after welding, using the same or a similar epoxy at each joint. And if the mainline coating is CML, we'll be filling in with cement at that joint.
I was just going to say, for the non-pipeline people amongst us, let's just clarify, CML stands for cement mortar lining. And are there any specific applications where CML may be preferred?
Yeah, so maybe a bit of a generalization, but CML or cement mortar lining normally used for smaller pipes. It's quite a thick layer of cement that you're putting inside the pipe. So with small pipes, that additional weight can be managed. But with larger pipes, the CML lining makes handling and transportation quite difficult. You can imagine if you have a big steel pipe with a thick cement lining inside, to lift that becomes quite tricky, for example. Then CML joints, they can be done without anyone climbing into the pipe, typically by pigging or similar methods. And that's a requirement for small pipes. You're not allowed to let people enter. And that also works well with flanged or other coupled type joints.
Okay, I think that's very helpful. Thank you. I know that CML is often used in water pipeline applications, and as you indicate, the application doesn't require as many people on the inside of the pipe, so can be termed perhaps a little easier. So let's then look at epoxies. Where would they be used? And then we'll explore that a little more.
So again, not always the case, but generally epoxy is normally used for larger pipes, which are joined by welding them together on site. And yeah, in that case, someone needs to enter into that pipe to complete the joint. The limit's determined by law, but normally above 700 millimeter diameter is okay for someone to climb in. And normally they'll be climbing into 1 or 2 pipe lengths to complete that joint. And just want to mention here, it's very important to limit the depth and the amount of pipe lengths that someone climbing in there to do the joint has to go, because if the further you go, there's a lot of potential or possibility of damaging the factory coating and other field joints. So we need to limit how far someone is crawling into the pipe to complete those joints.
Indeed. I just want to share this little picture of the size of the inside of the pipe to just demonstrate how small and cramped it is. And when you're talking about a 700 millimeter pipe, that's not a lot of space to do anything, let alone to actually do your work. So we can understand that. Now, having said that, we've got this tiny space and we still need to do some work inside the pipe. So what are we needing to do when we get into this little tiny space?
Cool. So yeah, basically we need to prepare the surface, and I guess all of you by now probably know how important surface prep is. And then we need to apply the coating. So internally, we normally have blasting specified, typically to SA3, which will be to the weld and the uncoated area, or that uncoated area might actually have a sort of holding primer that's applied in the pipe shop. So we're going to blast that to SA3, and then we're going to do a sweep blast to about 50 millimeters to lap over onto that existing coating that the pipe came with. Sometimes we'll also do a solvent wipe over that old coating to ensure you get a chemical and mechanical bond. Then we're going to apply the epoxy. That's often supplied in squish packs. A squish pack is basically a small volume of epoxy, about enough for the repair area only, packaged for ease of use on site. I don't know if there's a picture readily available now, but the epoxy part A and B are packaged in a single plastic sleeve, but separated with a little divider, which is removed on site, allowing the epoxy to be mixed by squishing in the plastic sleeve on site.
We did look at squish packs when we were doing external liquid repairs, but you can definitely see how that is much easier to use than big volumes when we're inside the pipe. Just a quick question before we move on from that. You mentioned that you've got a sweep blast, which you're obviously doing while you're inside the pipe. Do they coat immediately whilst they're there, or do they then go out and clean it and come back and coat?
As soon as the surface is clean, we want to coat as soon as possible to prevent any other dust or any other contaminants on the surface.
We've raved about squish packs, how convenient they are, but with everything there's a con. So what's the drawback with squish packs?
Yeah, so ultimately they're quite sensitive materials, and they need to be packaged and stored correctly. And those little dividing mechanisms are also quite sensitive, and they can sometimes malfunction, causing those materials to sort of partially mix and harden, making it unfit for use. Sometimes they also need to be kept cooled in cooler boxes to improve the pot life. And maybe just the last thing, because mixing is manual, it needs to be kind of just double checked that both parts are mixed together properly and completely to ensure the epoxy functions as desired, and that there's no sort of human error when it comes to the mixing. And then lastly, we just need to consider always the compatibility with the mainline coating of what's in the squish pack, and if there's any other criteria that needs to be accommodated, like potable water certification, that's taken into account as well.
Right. When we talk about the mixing of the squish packs, I know some of these liquid coatings have really short pot lives. Do you have enough time to mix them before you go crawling in, or do you do the mixing inside the small hole?
Yeah, so some of them it varies from product to product, but some of them will have very limited pot life. So you'll probably be mixing inside
as you're crawling.
Yes.
Oh my goodness. Okay. I admire anybody who does this, but one of the other concerns that I'm thinking might happen, and actually it's coming from the floor, is what about fumes? I'm sure that's something of concern.
Yeah, that's a good question. And, for the fumes reason, these products that we are going to apply, these epoxies are normally solvent free, or in another way of saying it, 100% volume solids products. So there's nothing that's evaporating out of that coating that's going to be harmful to breathe in or potential health or other risk.
Yes, because that's something one does want to take into account. So just having looked at the practicalities and dealt with some of that, I'm sure there are other factors that can complicate the process. Arto, you've been very silent. What other considerations do we need to give to this little exercise of coating on the inside of our pipe?
Comparing the field application, internal joint application, compared to what they have applied into the shop, you're working with two completely different environmental conditions where you've got much more stable temperatures in a warehouse where they typically paint the rest of the pipe. Now you're in a trench in the sun. You've got possibly extreme environmental conditions fluctuating between night and day. The top of the pipe is hot, the bottom of the pipe is cold. Exactly like you said, the effects on the pot life is the guys tend to take cooler bags, little cooler boxes with them with ice in to keep the product cool, and just to give them that little bit of extra lead time so that they can do their work without the product setting on them in this pipe that can get very, very hot. Sometimes the temperature of the top pipe can get above the product recommended temperature, then you have to wait. I mean, that pipe might be in the sun. Exactly, the work quality can drop because of the heat in the pipe and the constraints and the fact that it's very difficult to work in these pipes. The workmanship, the quality of the workmanship just tend to drop because it's just difficult. There's no light. Like you said, ventilation. If you don't have ventilation, you've got very high humidity usually in those pipes that can have an effect on your product application, your product curing, blooming, blushing, and also the guy in the pipe that can cause him to sweat a lot. And that sweat, if that sweat drips on the prepared surface and you accidentally apply over the salty water, you're just aggravating any kind of a rust or any kind of a contaminant that you're going to be painting over. So you've got to be really careful with a lot of these things.
I hadn't thought of the humidity at all. I'd thought about weather conditions on the outside, but you're absolutely right. Considering the conditions on the inside of the pipe, wow, you've just opened my eyes to that, and ventilation, obviously. In fact, I don't think I've got the courage to do that job actually going into the pipe. Yeah, we fairly glibly mentioned at the start of the conversation, Arto, that we can climb inside pipes that are 700 millimeters, but that's really quite small. Do you have any idea how big this pipe was?
I think that was Ben, that was an 800 or a...
That's 800 nominal bore, yeah.
Yeah,
okay,
that's an 800.
Right. So that's quite big. Oh, yeah. Goodness me. And we can just see there just the constraints, the practicality, but I can imagine a smaller pipe than that, trying to apply the coating, as you said, dripping sweat everywhere because it's so hot. Are there problems with the coating if the pipe gets so hot, or there's such a differential in temperature around the pipe? Are your products, or are the products that are available quite flexible in TAN?
You can definitely run into problems if you see the specific product being used, limitations. Most of the products used, they do have high, it's going to be for the high and the low temperatures, but obviously it depends where you are. If you are in the middle of Botswana, or Nigeria, you've got extreme conditions, and you're going to struggle to get products that can really accommodate those conditions. You're going to really try and plan around applying early morning or late afternoon when it's a little bit cooler. And if you have to control the environment with fans or some kind of a ventilation, then that's what you're going to have to do. At the end of the day, you're going to have to read the data sheet and make sure that you follow the recommendations on that.
Right. When we were talking about using liquid coatings, we mentioned the practical use of kind of a shade or an awning over the pipe. And actually, that would be quite practical to help you on the inside of the pipe, which again, not crossed my mind on a practical level, but that would control your temperature a little bit more because the sun isn't directly baking onto the pipe.
Absolutely.
Just the lighting, you mentioned that.
Yeah, torches, headlamps, any kind of a light that they can bring in with them. If you go into the pipe, you can, but you typically don't want any kind of a tool on a lead. So you've got battery operated tools wherever you can. Okay. You don't want traffic. And when I started with StonCor, with my interview, they didn't ask me if I've got claustrophobia, but I actually do. And I struggle to go into a pipe for longer than two lengths. And Ben knows this. Ever since I've made who I report to aware that I've actually got an issue with going into this pipe. If we interview somebody, that's one of the questions that comes up. That's just an interesting side fact. When you crawl into the pipe for some time, you can really feel the pressure. Well, that depends on the individual, but you can really feel the pressure of the confined space pressing in on you, especially me.
I'd also not thought of is this isn't two pipe lengths on their own. Of course, they are joined to the long mainline pipe. So although you're only going in two pipe lengths, you haven't gotten out on the other side.
No.
Well, not an easy out anyway. Yeah.
Typically, you can't spray in these pipes, so you're going to have to brush and roll, and that brush roll, or you'll use application pads, and that again, that's going to influence the quality, the end quality of the product, the application quality of the product. You're standing the risk of inducing air if you over brush and roll. So they use trolleys or skateboards to enter these pipes, and that is just a lot of traffic on the bottom of the pipe, which you then, when you come out piece by piece, you've got to fix as you move out.
Yes, that is something that I think maybe isn't taken into account, is that you're creating damage by fixing damage, and that can cause challenges, as you say, on the way out from the wheels. Yeah, someone's going to have to come up with a clever solution to that, and there must be something we could do. We just haven't thought of it yet. But quality is obviously your passion, because you've mentioned it a couple of times. And if I'm thinking now about the quality person, we've had our applicator go in. He's done, presumably in one pass, he's done the preparation and the coating. Is it now a second trip in by somebody else to do some quality control?
Unfortunately, yes. So what you kind of want to do is you want to prepare it as well as you can. Then you want to apply the product as quickly as you can before any kind of a contamination sets in. Then you want to try and do all your QC tests, like your DFT and your holiday testing, as soon as you can. And once you've moved back from that weld, you don't want to go further or past that section again after you've quality tested it. In Neil's words, you maybe want to call it a quarantine. After you've done your QC checks, you want to move out.
Yeah, I can understand that. The fewer people who go and interfere, the less damage they can do. And it's usually the external, so not necessarily your certified coating inspector, but someone else who just wants to have a quick look, who actually can inadvertently cause more damage than is practicable.
That's exactly that. So unfortunately, with these pipes, it's not comfortable to go in. So the guy with the qualification isn't really in the mood to go in there. At the end of the day, you'll rather send someone to go in. And unfortunately, that guy's got a lot of rocks and stuff under his boots. He's not sure what he's doing. He's going a little bit too far. You've got these things happening on these sites because it's so uncomfortable area to work in.
I've had a question from the floor, just asking for verification. If you do introduce cross ventilation, so some form of positive airflow to cool it or give you more oxygen or calm the person who's panicking because it's a confined space, I presume that you'd have to verify that won't negatively impact the product.
If you would have to verify that, but if you've got a solvent-free product, that would depend on the temperature and the flow of what you are introducing. If you're just introducing a light flow of air to remove some of the humidity, but not a wind, it shouldn't be an issue. If you're using a solvent-free product, if you've got a basically it depends what you're introducing, but it shouldn't be an issue if you're introducing a mild flow just to lower the humidity and get some air through there to drop the temperature a little bit.
Going back to where we were just now talking about quarantining, which just seems so sensible. I know there was a project a few years ago where the contractor actually elected to do all of the repairs after installation was complete. And so they were entering from access points, the valves, at approximately 500 meters, and were going in 250 meters. And not only was that terribly difficult practically, extremely challenging in terms of how they did it and everything. They had air issues, they had traffic issues, huge amounts of damage. As you said, you've got people in and out and traffic damage. And it actually ended up delaying the project by about 2 years. So I think for our audience, who's primarily engineers, who are often involved with the planning of this, please heed that warning and really try to understand that the most practicable way really is, as you say, 1 or 2 field joints at a time, because any more than that, A, becomes physically very difficult, but B, can cause a lot of damage in the pipe, which then is just an awful nightmare. Yeah.
Yeah.
Ben, you also have some comments in this regard. We do spend so much time making sure that our coatings are defect free, and then you've got an opinion in this regard.
No, it's just very general, but just to close off from my side, so we spend so much time and effort on the main pipeline coating in the fab shop in terms of painting it or in the prep and the painting and all the QC. We really go to great lengths to ensure that that's done properly and for good reason, And as with the externals, but especially given what we've discussed in terms of the extremely difficult conditions in all senses that we've mentioned, it's just such a pity that the internal field joints don't get that same attention, because it really is a really critical thing. It's very difficult to get right, and just want to encourage everyone to give it the attention that it deserves.
And thank you, Ben. I completely concur, and that's really why we've tried to do this little bite-sized corrosion series, was exactly that, to talk about something that's sort of the poor stepsister, who the Cinderella of the pipeline, and understand that actually it can be absolutely critical. And Arto, from your side, obviously from the quality perspective and as an inspector, just that people talk to each other.
Yeah, absolutely. Just amplifying Ben's point, the wild areas are really the risk areas in the completed pipeline, because, just again, reiterating Ben's point, those are the risk areas, because unfortunately it's the nature of the situation that those you can't really follow the same procedures that you do in a shop, and therefore it is really paramount that everybody coordinates and communicate properly so that it's a seamless and smooth transition between welding inspection, surface preparation, coating, all QC procedures being followed through, and then moving away from that section so that there's no traffic over that again.
Absolutely, really profound. Thank you for that, Archie. I think if there's something that you take away from today, let it be that. Don't forget about the field joints, and very especially don't forget about the internal lining, because if you plan it properly, program it properly, don't let the fact that the construction has delayed everything and now there's the crunch, water's got to be flowing next week. That shouldn't be the excuse to do a poor job. We really need to focus on doing it right. So thank you to both of you for joining us and helping us explore this a little more. Our time has really flown, and we've reached the end of this series on the coating and lining of our pipeline field joint coatings. And I hope that you've learned as much as I've learned, and how practical we really need to think about this situation. And of course, special thanks to all of my guests who've helped us through this series.